Today we're going to talk about the inverse of a quadratic function, which is a lot of it is review for us. So this is actually section 1.5, and you can go back and look at that if you've forgotten. When we have f inverse at x, so the notation is we have a negative sign, -1 exponent, it means we're looking for a reflection through the line y equals x. And if you look down here on the graph picture, here's the line y equals x. And the original parabola that was here, this is our basic quadratic, x squared. This is what it looks like if it gets reflected. So if you folded it along this line right here, and this was made out of wet paint, and you folded it here, you would have this imprint left behind. This is its reflection through the line y equals x. So up to our second box here, what was the domain of your function becomes the range of your inverse and so on, because you're switching x and y's. There are two ways to graph a function's inverse. One is to use the graph of the function to graph the inverse by switching the x and y coordinates, and that's easy. Okay, if you have a coordinate on your original function, let's say off of this one here, we've got the point 2, 4 is right there. 2, 4 is going to go 4, 4, 2. So we just switch the x's and the y's. The other way to do it is to use the equation of the inverse to graph the function, and that's harder because to get the equation, if you remember, we have to back up to the top, we have to interchange the x and y, and then we have to isolate for y and all that, so it's a little harder. In the equation of the inverse of a quadratic function, the positive square root function represents the upper branch of the parabola. So the positive square root here is the inverse of this side right here. And then the left side of the parabola, its reflection side is this piece down here. Example 1. F at x equals x squared is a function, and we know it well. Here it is right here. This was your big function in grade 10. Its inverse is written like this. Now we notice here I put y equals. You can't write f inverse at -x because it's not a function, so we can't use function notation. We have to use a y. But what we can do is we can restrict the domain so that only one branch of the inverse is used. So we go up to our original right here. I'm going to take that one and I'm going to restrict the original domain. Restrict the original domain so that only one branch of it is used. So the way I write that is f at x. So my original function is f at x equals x squared. But I'm going to write here that x is greater than or equal to 0. And that means when you're graphing the original graph, you can only graph, so if I subbed in here, I could sub in f at 2. 2 squared is 4. So 2, 4, I'm going to put that dot, it's already there, but I'm going to put that point there. So that point is good. But on the other hand, f at -2, oh, that's not allowed, right? That's not my domain, so I can't even graph that one. So if I restrict my parabola to, I'm going to try to draw it on here with my tablet. If I restrict my parabola just to this side, then that means my inverse will be a function too. And my inverse will only have one side as well, this side right here. And if you're unsure about which side, once you restrict your domain, which side to write, you take a point on your original, so on the kind of the green side there, I put that point 2, 4, 2, 4. So that means on the inverse, I should have the point 4, 2, which I do. Right here is 4, 2. That tells me which side I'm using. So because it's not, because 4, 2 is not down here, I know that this part is the part that was erased. So now my inverse is a function. So now I can now say f inverse at x equals the positive square root of x, because I got rid of the bottom. So one important thing to remember about when you're taking parabolas and writing their inverse, if the original quadratic opens up, like this one here, your a value is greater than 0, yet it opens up, it means your inverse is going to open to the right. If your a value is negative, so if I had a negative a value, then my inverse would open to the left. Example 2, determine an equation for f of x in standard form. And then I put a little note here. You can use the zeros and start with the equation in factored form, or you can use the vertex and write it in vertex form. In either case, you'll have to find an a value and then expand to standard form. So the question wants the answer to be in standard form. So let's look at vertex form. What's a vertex? I think that vertex, when I look at it there, it looks like it's at about -1, 8. So in vertex form, I have an a value. I haven't thought about that yet, but I know I've got x plus 1 squared plus 8. So how do we get the a value? We pick another point on the graph and we sub in. So you can pick any point you like. I can sub in, looks like a y-intercept here of 0, 6. So the 6 goes here. It's always helpful to label. This is my x, this is my y. 6 goes here. 0 plus 1 squared plus 8. That gives me 6 equals 0 plus 1, so that's 1 squared 1, so that's just going to be a plus 8. Bring the 8 over and we get -2 equals a. So my function in vertex form is -2. So remember, when we're doing vertex form, we either look at the a or the k value. We don't need to find both when you're given a graph, because when you're given a graph, you can't tell if it's been a vertical stretch or horizontal compression. So we just pick the a value. So there's my equation in vertex form. And let me just underline here. It says use the vertex and write it in vertex form. That's what we just did. We found the a value, and now we have to expand to standard form. So we still have to expand it out because the question did say in standard form. So expanding it out, remember that exponent means write it out twice. It does not mean x squared plus 1. So I have to write it out twice. That's what the exponent means. Plus 8. And that gives me, I'm going to do the binomial expansion first. That will give me x squared plus x, so that's plus 2x, plus 1, plus 8, and I'm running out of room. F of x equals, distributing in, I get -2x squared, and then -4x, and then I'll have -2, but I also have a plus 8 out there, so -2 plus 8 is plus 6. So there's my answer in standard form. And we're going to do it both ways, because the other suggestion is we can use the zeros and start with the equation in factored form. So let's do that. Factored form. Looking at the zeros. So on the graph, let me label them here. That's a -3, 0, and this one here I think is 1, 0. So in factored form, again, I don't know my a value. Normally would not have to do this twice. I'm just showing you how to do it twice. X plus 3 times x minus 1. Now to find the a value, we could sub in the vertex if we wanted to, or we could sub in our 0, 6 point again. You pick a point and sub it in. Let's pick the same one as before. 6 equals, my x is a 0, so that's just going to be a 3. My x is a 0, that's going to be a -1. 6 equals -3a, divided by -3. And what a surprise, we get -2 equals a, which we already knew, but that's okay. We would only do it once, you wouldn't do it twice. So our equation in factored form is f of x equals -2, x plus 3, x minus 1. And now, again, it says, the question said standard form, so we're going to have to expand all of that out. So why don't you do that? Expand it all out, and when you come back, see if you have the same answer I do. And of course, it expands out to exactly the same answer that we got the first time. The question doesn't tell you what form to use, and you can pick a form, and usually on my tests I often say using the method of your choice, so you would do this whichever way you prefer. Now part B says graph the inverse of f of x. So we have lots of ways to do this. We have equations for f of x, but we already have a graph for f of x. So what we're going to do is we're going to take the coordinates that we already have here, and we're just going to switch them. So the x and the y are going to switch places. So negative 1, 8 is now going to be 8, negative 1, which is right on the edge here. 8, negative 1. That's the new vertex, right? That's like a transformation. It's like, where did this vertex get transformed to? Well, it got transformed right to there. Now, remember what I said previously is that if your graph is opening down, or you have a negative a value, like we do, then your inverse is going to open to the left. So opening to the negatives here, my original graph is going more and more negative. So that means my inverse is going to open to the negative values as well. Let me erase that stuff. All right, so I've got the vertex. Now I'm going to take the point 0, 6. It's going to go to 6, 0. 1, 0 is going to go to 0, 1. Negative 3, 0 is 0, negative 3. So right there, these 2 points I'm putting on the y-axis right now, clearly I'm not going to have a function because that's going to fail the vertical line test. But anyway, I've got enough points here to make a nice smooth quadratic coming out like this. That side doesn't look as smooth. It got kind of pointy there. My pen got cut off. Okay, so that's my inverse right now. Right now, all I can call this is y inverse. I can't use function notation because it's not a function. You draw a vertical line, it's going to fail, so it's not a function. But that's what part B asked for, and it just asked us to graph the inverse, so we did that. And part C says, determine the equation for the inverse using a plus or minus sign. And here's something good to remember. It's easiest to use vertex form. So whenever you're doing this in your homework, if you have multiple forms to pick from, vertex form is usually the easiest one. And why is it the easiest? It's the easiest one because, let me get my highlighter on here, because in vertex form here, there's only one x. Whereas in factored form, I've got, there's one x, and I keep going, there's another x. So the reason why 2x's is worse than 1 here, or standard form, look at standard form. Standard form's got 2 x's in it as well, but 1 squared. I'm going to have to isolate x, right? I'm going to have to isolate it. It's much easier to isolate 1 than it is to isolate more than 1. So I'll show you what I mean here if you're not following me on this one. I'm going to start by writing the equation, but I'm going to write it with y equals because I have to switch x and y as my first step. So I'm going to write y equals instead of f of x. Negative 2 bracket, sorry, x plus 1 squared plus 8. So I'm using this form right here. Now, step 1 is to switch x and y. So here's where you can see I only, well, now my step 3 is to isolate y, and I only have one y, so that makes it really easy. Imagine if I was using this form right here and I had a y there and a y here. How would I isolate y? That would be really hard. So I'm going to subtract the 8 first. Remember, when we isolate, it's the opposite of bed mass. If I write bed mass backwards, SAMDEB, I have to do subtraction and addition first. That means I'm going to subtract 8 first from both sides. So I'm going to get x minus 8 here equals negative 2 y plus 1 squared. Now I have to do multiplication division, and all I have to do here is some division. Divide both sides, this side and this side, by negative 2. So I'm working out kind of on the outside all the way into that y. I've got to get rid of everything outside away from the y before I can get close to the y. So let me move this over here a little bit where we can see it. See that negative in the denominator? Now, we're not supposed to have negatives in the denominator in math, so I'm just going to move it up. So that's a negative x, and then of course the 8 has to change as well. Over, now we have a positive 2, and that's going to equal, what's left over here is y plus 1 squared. Okay, so we did subtraction, addition, we did multiplication, division. Now we have this exponent to get rid of, where you take the square root of both sides. And in the question it says using a plus or minus. So plus or minus the square root of negative x plus 8 over 2 equals, now I just have y plus 1 because the square root and the power of 2 cancel each other out. So my last thing, now that I'm at the B of bed mass, the very first thing, which is now the last part of SAMDEB, I am inside the brackets. I can now get rid of that 1. I'm going to bring the 1 over, and I'm actually going to put it in the front. I'm kind of out of room, so I'm just going to take this, I'm going to subtract 1 from this side, and I'm going to put it right here, minus 1. You could have also put it on the other side of the radical, but I'm putting it at the front. So that is our equation of the function, of the equation of the original function in inverse. Now, is it a function? Does this look like it's a function here? So for sure by this, and I can put the exponent -1 to show it's an inverse, but it's not a function, so I can't write it as f inverse of x because what I've written here is not a function. That would be really hard to graph, right? Imagine if all I gave you was this right here and said graph it. That would be extremely tough. So it's much better to graph it the way we did originally. All right, let's look at example 3. A certain word problem has some restrictions on its domain. So we don't really know what the problem is, but we just know it's got these restrictions. Its function has this equation, and so we're given this domain. These are restrictions on the domain. Find the range. And I'll talk about this little piece in a second here. Let me scroll down a bit more. Okay, almost at the end. So here's some helpful tips maybe down here. Get my highlighter out. Oops, visualize the problem, draw a diagram. It doesn't tell us to draw a diagram, but I almost always do because why not? It helps us to visualize what's going on. And because the question said we're trying to find the range. So range, we need to know kind of maximum or minimum values. So since we're looking for maximum or minimum values, the diagram will help us with that. Since the domain is restricted, then the range must be restricted as well, subbing the endpoints of the domain to help determine the range. Okay, let's get going here. So let's start with drawing the diagram. Now I have an x and a y axis here, I have a grid here, but I have no scale on it, so I'm going to put my scale on. When I look at the question, I can see that it's a quadratic. I can tell if I were to look for the vertex is important always, so let's find the vertex. I'll do that down here. Vertex, f at x, so I'm going to use, there's lots of different methods I know from previous lessons, but I'm just going to do completing the square. It'll be quick because I just have I don't even have 3 terms here. X squared minus 2x. That's all. I have no extra number to leave outside because there wasn't one. So my next step is to take half of the middle term. So I'm going to take half of 2. So take your middle term, you take half of it, and then you take that and you square. So that's going to be half of 2 is 1, 1 squared is 1. I add 1 and I subtract 1. That leaves me with 3 x squared minus 2x plus 1. I take this minus 1 out. I have to multiply it by the a value. Multiply it by 3 minus 3. And I get 3. Let me erase this stuff here if I can. And then my trinomial, I've created a perfect square. I've completed a square. It's going to be x minus 1 squared minus 3. So now I know my vertex is going to be at 1, negative 3. Okay, vertex. So with small numbers like that, I don't need to count by tens or anything on my scale. I can count by ones. I could probably even count by halves. I think I'll count by halves on my x-axis. So I'm just going to label, I'm not going to show my counting by halves. I'm going to count every second one. So I will do that along my x-axis. Now you can't change. I can't all of a sudden on the left-hand side of the x-axis start counting by fives. I have to use the same intervals that I did before. But I can change for my y-axis. And I will, because parabolas, as you know, they get really tall really fast. So I don't want to spread those out. So I'm going to count by ones, but again, I'm going to label every second space here. Now I'll place my vertex, which is 1, -3. Yeah, the question didn't say you have to graph it, right? So if you really don't need to graph it and you can figure out the question, then go for it. 1, -3 is my vertex. I know it's opening up, but it has an A value of 3, so you can use whatever method you use for graphing. If you use a step pattern, I'm going from here, I'm going to go over 1, and instead of going up 1, which would be how we would graph the basic function, over 1 and up 1, I'm going to go over 1 and up 3. 1, 2, 3, because my A value is a 3, and symmetry on the other side. Back to my vertex, instead of going over 2 and up 4, which is the basic original graph, over 2 and up 4, I'm going to go over 2 and up, instead of 4, I do 4 times my A value, so I have to go up 12. So I was at a -3 and I'm going up 12. Oops, I just realized I'm counting by 0.5, so I'm going to have to erase those dots there. I was supposed to go over 1, but because I'm counting by 0.5s, I ended up going over by 0.5s instead of by 0.1. So I'm going to erase my 2 dots here if I can. Erase these ones, and then I'm going to fix those. Okay, let me do that again. Over 1 is actually 2 spots, right? So over 1 and up 3. Here we go. Over 1 and up 3. Over 2 and up 12. So again, however you graphed quadratics last year, you just keep on doing that. This one is 3, 9. So I'm going to draw the parabola here. Now I remember I had a restricted domain at the beginning. I'm just ignoring that for a second here. I'm just focusing on graphing my quadratic. Whoops, got a bit bumpy there. Let's start from the top. A bit bumpy there too. Okay. So there's my quadratic. Now look back up to the original question. We have this restricted domain here, okay? This is our domain from -2 to 3. So -2 is here and 3 is here. So that means my graph can only go, imagine there being a big wall right here. My parabola can't hit, well, it can hit the wall, but it can't go past the wall. So that's as far as that can go. And the same thing right here, I can only go up to 3. So everything on this side of the wall doesn't count because it has a restricted domain. So only the parabola that's between those barricades is valid for this question. And what we're trying to do is find the range. So it's a good thing we have the vertex, because the vertex tells us the low point. So the lowest value we have here is our vertex. That was 1, -3. So the -3 is the lowest point of my range. Remember the way we write, I'll do range in a second. Now what's the highest point? So it's actually right here at 3, 9. Since we had an inequality right here, this is x is less than 3, this would be an open circle right here. If I had to graph it, if part of the question was to graph it, I would have to have an open circle right there, because it approaches that wall, gets really, really close to it, doesn't actually touch it. So we show that with an open circle. But what's the value up here where it's going to meet? So to find that value, I'm just going to sub in, and it said that in the in kind of the small pointed parts here. Let me highlight that again. Sub in the endpoints of the domain to help determine the range. So I already happen to do one of them. Let me switch colors here. How about blue? So the endpoints of the domain, if I sub in f at -2, when you sub in f at -2, what do you get? I want you to work that out yourself. Sub it in up here, f at -2, what do you get? F at -2, that would be a 24. So way up here, if I kept graphing way up here, I would be at a 24. The other end part of my domain was f at 3. We sub in a 3 and we get a 9 right there. We already knew that point anyway. So we didn't actually need to do any of that graphing, but it did need to because it was really hard for me to figure out this question without a graph. So I know my f at 3 equals 9. My graph goes higher than that. So that's not the upper limit of my domain. This is not, right? My parabola does not stop here. It's not the highest point because on the left side, so that's supposed to say not highest, because on the left side it keeps going. So my range is going to be y is an element of real numbers such that, now first you put the low number, it always goes low and then high. So my low number is the vertex number, that's a -3, and that's included in my domain, less than or equal to y, range, sorry, and then the high value is a 24. But that one doesn't get a less than or equal to because I would have an open circle up here. I don't have an open circle down here, it's closed, the vertex, it goes all the way to that point. So we include this, but we just do not include the very top point because we didn't have this symbol here, so we couldn't include that top value. If you don't understand something, like this question I just did, for example, there will be examples in your textbook for another explanation. And of course, I really recommend that you use your textbook because when you do get to post-secondary, you really need to rely on your resources to figure stuff out for yourself. So if you don't understand how to do, you still don't get this, watch the video again. Second time through will be much better for sure. So watch this video again or watch different videos or look through examples in your textbook. Good luck.